Hi, for this video what I want to show you how to do is to construct a 95% confidence interval using the TI-84 graphing calculator. What we have here is in a survey of 1,040 adults, approximately 46% of the respondents said the government should be able to access encrypted communication when investigating a crime. So anytime your problem has a percentage or a proportion in it, then you are going to use the one proportion z interval in order to create the confidence interval for this one. Okay, in order to use this one, there are a couple conditions that must be met in order for the central limit theorem to kick in. And the biggest one that you have to have is that p hat times n has to be greater than or equal to 5, and q hat times n also has to be greater than or equal to 5. In this case, since we have 46% of 1,040, that means that we have approximately 478 successes, and we have approximately 562 failures. So since both of these are met, then that means that we can go ahead and run the interval. Now, depending upon your course and how much work you have to show, I know that there are some professors or teachers that require that you show the work. So if you are required to show the work, you would write down the p hat plus or minus zc times the square root of p hat q hat all over n. You can also separate this out if that's how your textbook does it, but basically this is the shortcut to writing out the work. ZC, the easiest way to get this is actually from a table, but let's say that we don't have a table available to us and we have to find it in our calculator. So the first thing that I want to do in order to find this information here is I'm going to write down all of my important information. So p hat was given to us in the problem. That was the 46%. And we always put it in as a decimal. Okay. And q hat is always 1 minus p hat. So in this case, q hat would be 54%. And remember that these were approximated. So if you actually did this in your calculator, you may get something slightly different than if you used the 0.46 and the 0.54 in your problem. Okay, and the 46, like I said, the 0.46 came from 46%. So if you need to show work, what we would do is we would write our 0.46 plus or minus. I still have to find ZC, and I'm going to show you how to do that in just one second. And you have several options for finding your critical value. ZC, it can also be Z star. I know some textbooks use Z star instead of ZC, but that is just your z-score that corresponds to a 95% confidence level. So if I go back up here, I asked to construct a 95%. So our c would be 95% or 0.95. Okay, so n was, from the problem, was 1,040. So n is the number of people that we asked. So that would be our 1,040. And like I said, I'm going to show you how to find the ZC in the calculator, and this is just if you have to show work. If you don't have to show work, you could skip ahead and just see how to run this in your calculator. But I want to make sure that I show you guys how to show work in case that is a requirement for you. Now, to find ZC, or if it's not in the table, the easiest way to do this is to go to Second Distributions. And we're going to use the inverse norm. Because we're dealing with a z-score, we would use option 3. And the area is always going to be 1/2 of 1 minus the level of confidence. So in this case, it would be 0.95. And I'm going to choose left on this one. I am going to show you both ways on this because most calculators don't have the left, center, right option yet. Okay, this is a new feature in the newer color editions of the TI-84 Plus. So I'm going to ignore the left, center, right for just a second because most calculators only show the area, the mean, and the standard deviation. So I'm going to plug in the 1/2, 1 minus 95, the left like I said, ignore this if you don't have it. This is how you would put it in if you don't have the left, center, right. And then I will go back and show you what to do for the other one if you have this one. So we always round these to 2 decimal places unless it's directly in the middle. So since negative 1.9599 is very close to negative 1.96, that would be our z-score. Okay, again, if your calculator doesn't have the left, center, right, you would just put in the 1/2, 1 minus 0.95, 0, 1, and you can ignore the sign. The critical value, typically we write it down as a positive value because of the fact that it's symmetric and we're taking 95% of the area out of the center. If you do have the option that this calculator has, where you have the left, center, or right, you can actually just type in the 0.95 and go down to the center. That's just your level of confidence, and select center. And if you hit paste, it will give you both the positive and the negative critical values. So it's another option. But like I said, the center option isn't on a lot of calculators, so I wanted to make sure I showed you how to do it without that option available to you. Okay, so now we have the work shown. So now what we want is the confidence interval. And if you were doing this without the calculator, I did put in the negative. It really doesn't matter that it's there. Let me just erase that really quickly. It is okay if you put in the negative because you're doing the plus or minus. It will give you the same answer. It's just more work to have to put it in. So we would just put it in as 1.96. Again, this is just showing the work. Okay, the calculator will actually run that formula. It's programmed in here, and to find that, what you're going to do is you're going to hit Stat and go over to Tests. And under Stat and Tests, you want to scroll down until you find the 1 proportion z interval. Make sure you don't hit option 5, the 1 proportion z test. That's a hypothesis test, and we're getting a confidence interval. So we want to find the 1 proportion z interval. So if you scroll down, it's option A. And with this, it's going to ask you for X and N. X is your number of successes. So in our problem, because it gave it to us as 46%, what we can do is we can type in the 0.46 times the 1040. However, we can't leave it like this because remember, these are people that we're talking about, and I cannot poll 0.4 people, so I have to round it to the nearest number. So what I would do is I would come back up here and change this to 478. And then my N is the number in my sample, so that's the 1040. And then my confidence level is just whatever level of confidence. In this case, it would be 0.95. And you would hit calculate. And this right here gives us the interval estimate. Okay, so we would just write this down. It also gives us our p-value. Notice that this is approximately 0.46. Like I said in the problem, most of the time in the real world, we're not going to write out a really long decimal or a percentage. So most of the time we round it to the nearest percent. Okay, so let me go ahead and write down the interval, the 0.42933 to 0.4899. And depending upon however many decimal places it tells you to round to is what you would write down. And it's always important that you interpret this in context. So when you're interpreting this, you always start with the level of confidence. So we can say with 95% confidence. And now we have to insert the context. So the context of this one, if you recall, is it's the adults, the proportion of the adults who said the government should be able to access encrypted communication. So we would just write this out. With 95% confidence, the proportion of adults who believe the government should be able to access encrypted documents or encrypted communication during an investigation. This is kind of a long one to write out. And a lot of times when you're explaining this, you want to make sure that anybody can understand it. So with 95% confidence, the proportion of adults who believe the government should be able to access encrypted communication during an investigation is between, and you can either write this as a proportion in the form that it's in as a decimal, or you can write it as a percent. So we could say that between 42.9% and 48.99%. So you can either write it as a percentage or you can leave it as a decimal. There's a lot of different interpretations of this, but it is always important to make sure that you wrap it up and you interpret your decision in sentence form. Okay. Like I said, we could have skipped directly to the answer in the confidence interval, but a lot of times you have to show work, which is why I chose to do this. Hopefully this was able to clear things up for you. If you have any questions, please let me know. If there are additional topics you need me to cover, please let me know that as well. And as always, thanks for watching.